Alright, what's up, Algebra 1? We're going to do our final radicals video number 3. What we're going to do here, just to start, is 2 multiply problems. This is kind of review, so if you want to pause the video and try it on your own, that'd be a good idea. And then let's see how this goes. So, in number 1, I got to distribute the 3. And I get 3 times 3 is 9, plus 3 root 2. Because 3 times root 2 is an outside times an inside, so I just squeeze them together. Then I have to distribute the negative root 2 to the 3, so I get minus 3 root 2, outside number, inside number. You always write the outside number first. And then I do the negative root 2 to the root 2, which would be negative root 4, inside times inside. I can simplify some things here. First off, you might notice that I have 3 root 2 minus 3 root 2. Those are going to cancel. I also have root 4, which is just 2. So this problem turns into 9 minus 2, which is 7. Look at that. It just is 7, which is kind of nice. Let's see what happens in number 2. In number 2, I'm going to distribute the root 8. And I get root 8 times root 8 is root 64. And I get root 8 times root 3 is minus root 24. Then on the inside here, I take the root 3 and distribute it to root 8. So that's going to be plus root 24. And then root 3 times root 3 would be minus root 9. Okay, but some simplifying. Root 64 is just 8. The root 24 and the negative root 24 cancel. And then root 9 is just 3. So this problem really turns into 8 minus 3, which is 5. So we've got a little pattern going on here. If you'll notice, both the parentheses are like number minus number, number plus number, right? And so same thing on the bottom, number plus number, number minus number. So that pattern you might recognize as the way we factor a difference of squares, but that pattern leads us to something kind of cool here where the square root symbols disappear and we get a nice whole number answer. So let's look at that pattern more closely. We call that pattern a conjugate pattern here, or we call them conjugates. So if I took 2 things, a plus root b, the conjugate would be just changing it to a minus, a minus root b. Right? And when I put it in parentheses like that, I can distribute just like we did on the previous one. So a times a is a squared. A times root b would be minus a root b. Root b times a would be plus a root b. And then root b times root b would be minus root b squared. Because b times b is b squared. Well, let's look at our canceling again. The minus a root b and the plus a root b cancel. I get a squared minus, and then the square root of b squared is just b, right? So this isn't really you don't need to memorize this or anything. That's just kind of our answer here. But what we're noticing here is the square roots are gone. We get a squared, which is a nice number, and then minus b. There's no square roots anymore. So we're going to use this pattern, this idea of conjugates, for the next type of problem. And that type of problem is rationalizing the denominator. We've done this already, but now it's got a binomial on the bottom, right? So instead of just square root of 5, it's 3 plus square root of 5. So I've got to do something to get rid of that square root in the bottom. And the thing that we're going to do in order to fix this situation is something called multiplying by the conjugate. Multiplying by the conjugate. So, the way this works is I take the denominator here, 3 plus root 5, and I'm going to multiply by the conjugate of that, 3 minus root 5. 3 and the root 5 stay the same, I just change the sign to the opposite, so now it's minus. And I have to do that to the top 2. Notice how I'm using parentheses. You've got to put this binomial in parentheses, and we have to put the one that was already in the denominator, we have to put that in parentheses too. Okay, now we distribute. So on the top, I get 2 times 3 is 6. 2 times minus root 5 would be minus 2 root 5. Over, then I distribute on the bottom. I get 3 times 3 is 9. 3 times minus root 5 is minus 3 root 5. Root 5 times 3 is plus 3 root 5. And then root 5 times root 5 would be minus root 25. We can simplify the minus 3 and the plus 3 root 5. Those cancel. Root 25 is 5. So now my numerator is 6 minus 2 root 5. And my denominator is 9 minus 5, which is 4. Finally, because my 3 outside numbers all divide by 2, let's do that real quick. Divide by 2, divide by 2, divide by 2. I get a final answer of 3 minus root 5 over 2. So, one thing you might be wondering and noticing is if we're going to do this conjugate every time, the middle terms are always going to cancel out exactly, so we don't have to worry about them. They'll cancel out, and we can worry about just the beginning and just the end. So let's try that on the next one. Here we go. 3 over root 6 minus root 10, so I'm going to multiply by the conjugate. So I'm going to go times root 6 plus root 10. Root 6 plus root 10. Again, my goal is to get the square roots out of the bottom, and the way to do that is to multiply by the conjugate. So here we go. Let's do that. On the top, I'm going to go with equals 3 root 6 plus 3 root 10. On the bottom, okay, here's where we're going to start to try to shorten it up. Root 6 times root 6 is root 36, but isn't that just 6? Root 6 times 10, and the negative 10 times root 6, those are going to cancel out, so I don't even have to do those. So then finally I have to do the negative root 10 times the root 10, which would be minus root 100, but that's just 10. So this is what I get. And then we can simplify that to 3 root 6 plus 3 root 10 over negative 4. And there's our answer. And one more. Rationalize the denominator. This time the denominator is 7 plus root 3. So I'm going to multiply by the conjugate, 7 minus root 3. Okay, and put parentheses around that one. Ooh, here's a binomial 2 on the top. I got to put parentheses around it. Anytime you see a binomial in a fraction and we're going to be multiplying, you need to put parentheses. Okay, distributing time. 5 times 7 equals 35. 5 times negative root 3 is going to equal negative 5 root 3. The negative root 3 times 7 would be negative 7 root 3. And then the negative root 3 times negative root 3 would be negative root 9, but that's just negative 3. Over, on the bottom I have my pattern. These are the conjugates. So I can do 7 times 7 is 49. I know the middles are going to cancel out, so I do root 3 times root 3, which is just 3. So I do minus 3. Final, let's simplify. Let's see, 35. I have some like terms on the top. I've got the 35 and the minus 3. So that's going to be 32. And I have the negative 5 root 3, negative 7 root 3, which would be negative 12 root 3. Over 49 minus 3 is 46. Those all definitely divide by 2. So let's start with that. Divide by 2, divide by 2. We get 16 minus 6 root 3 over 23. And that will not simplify anymore because 23 is prime. So we are done. All right, we'll practice this more in class on Friday. Thank you for watching.